So in the second video, we are going to discuss counting and probability problems in AMC 8. And these two topics are very important in AMC 8, not only because in recent years, every year there will be at least one counting problem, there will be at least one probability problem, sometimes there are more, but also counting and probability problems are generally hard. So you need to find the right formula or right method to solve them. And regarding probability, in essence, it's actually simple, which means A over B. What is B? B is the total, all the possible outcomes, the whole space. And what is on top? What is A? Which are all the desired results. So it's A over B, it's just a fraction. In other words, it's two counting problems. And the first counting and probability problem in AMC 8 this year is question 6, which also relates to geometry. So let's see the picture. So in this picture, we have a grid which forms a square. And this question is good in the sense that we need to calculate the probability, we need to know what is A, what is B. They already give us one number, which is actually the denominator. Because they see this is a 9 by 9 grid, so altogether there are 81 points. So we are considering the points besides the center. So there would be in total 80 points. And we denote any such point by Q. And then what are the desired result? The desired result is PQ forms a symmetric line of this square. So how many symmetric axes for a square? We know there are two types. One is the two diagonals. You fold the square along the two diagonals, you will get a triangle. And that's two symmetric lines. Then the other two symmetric lines would be just the line that bisects the opposite side. So which means a horizontal line, a vertical line, and a horizontal line here. So that would be the four symmetric lines. And the question is to ask when Q or PQ can be a symmetric line. So effectively speaking, in order to get the numerator, we need to count how many points in these four symmetric lines. It's a little bit complicated that these four lines share a common point, but luckily this middle point is not in our consideration. So then these four lines actually can be regarded as 8 rays starting from the center. So you have 8 rays, then you only need to count how many points in each ray. So along the diagonal direction, you have 1, 2, 3, 4 lattice points. And along each vertical or horizontal direction, you will see it always have 4 points. So 8 rays, each ray has 4 points. So 4 times 8 would be the numerator. Now the last step is to do the simplification. Remember, when you do a simplification on a fraction, never do the things is to multiply the numerator or the denominator together. Instead, you should do factorization. So 80 you should write as 8 times 10. Then this 8 on the bottom can cancel with that 8. Then we have 4 over 10, where there's still a 2 as a common factor. So the final result would be 2 over 5, which is the correct answer to these questions. The question is question 11. So this question discusses about whether students take a math class or a foreign language class or both. So there are two criteria. Whether one is math class, the other is foreign language classes. When there are two criteria, or mathematically speaking, there are two sets. We do the counting related to the two sets. What is the formula? there will be a formula called principle of inclusion and exclusion. If you haven't learned this formula, you can Google it and get what does it mean. But it has a nice name. It is called PIE, pi. And related to this formula, what would be the picture looks like? That picture is called Venn diagram. Simply speaking, we just draw a circle for each criterion. Now we have two criteria. So some students attend math class. Some students attend foreign language class. If we want to count all the possibilities, so there should be some students actually take neither of the class. So a standard Venn diagram would be looks like that. So the area outside of the two circles means students that take neither of the two classes. But in this case, if you read the question, they see every student takes at least one class. So which means what? Which means we don't really need to draw the exterior rectangle. So all the students must lie in one of the two circles. Then we can continue to read the conditions. So how many students attend math class? That would be 70. So we can write 70 in this circle, which you need to remember in your mind that this 70 actually means this part plus that part. Then how about the people that take foreign language classes? So that is 54. So we write 54 for this circle, which means 54 includes this region and the common area. So now we add these two numbers together. What would we have? We have 70 plus 54. That is 124. Okay, what's the other condition we have to use? That is how many students are there. Altogether, we have 93 students. Oh, why 70 plus 54 is greater than 93? That is because there's a common part. So for any student that attend both math classes and foreign language classes will be counted twice in this formula. So we know what? If we make a difference, so 124 minus 93, where the result is 31. What does it mean? That means 31 students takes both math and foreign language classes. Okay, now is the last step to get the answer. The question asks how many students take math but not foreign language class. Of course, it should be this region. How to get the number? 70 minus 31. And the result is obviously 39. That is the correct answer. So once you use the Venn diagram, everything becomes super clear. That is question 11. 15. And that's a probability question. But this question is similar with the previous question in the sense that they also can consider two criteria. So we have a bunch of people here on the beach. We consider whether they wear sunglasses or they wear hats. So we can draw two circles to denote the two types of people. So the left circle would be mean people wear sunglasses, and the right side circle means people that wear hats. Then next step, let's write down the condition in the picture. Hopefully we can then solve it. So 50 people wear sunglasses, which means this circle. And then 35 people wear hats. That is the right circle. Now the next condition is the key. So 2/5 of the students, no, not the students, no, 2/5 of the people that wear hats also wear sunglasses. So here we have a fraction. The fraction is 2/5. Then what is the whole portion? The whole portion should be this right circle. And among them, there are 2/5 of people wear sunglasses. So if we do a multiplication, 35 times 2 over 5, so 35 is 5 times 7, so that's the result should be 2 times 7, which is 14. That is what? That is how many people actually in the middle of the picture. So 14 is actually the number of people that wear both sunglasses and hat. Okay, now we analyze all the conditions. Next step, we look at the questions. The questions is asking about a probability. So remember, when you have a probability, you have a denominator, which is all the possible outcomes, and the numerator, which is the desired results you want. So here, what would be the total? The total is, they say they have assumption. So we need to select the people that wear sunglasses, which means you need to select the people from here. So what should be the denominator? Actually, don't need to do any calculation. The denominator is just 50. 50 people with sunglasses. So what is the numerator? They say among all of them, how many people wear hats? Of course, it's 14. So you directly get the answer. But you can see there's no such fraction in the 5 choices. That's because it's not a simplified version yet. So both are even numbers. So we reduce the common factor 2, we get 7 over 25. That would be the correct answer. Don't think the designer of this question wants students to solve by just using that powerful formula. And actually, if we just use the simple enumeration method, which means the casework, you list all the possible scenarios in an organized way, you can still get the answer very quickly. Okay, let us see how we solve in this way. Remember, we have the equation, which is A plus B plus C equals 24. And what are the restrictions? Both are positive integers, and every number has to be at least 2. So we can start the enumeration from A. So let's see what happens if A equals 2. If A equals 2, of course, B plus C is 24 minus 2, that is 22. Then we can count what are the possible numbers for B. B is at least 2. What is the maximum possibility for B? You can see, given that C cannot be too small. C has to be at least 2. So if C is 2, B is 20. So that should be 20 should be the largest possibility for B. Then from 2 to 20, how many possible cases are there? From 2 to 20. And remember, the answer is not 18. Because from 1 to 20, there are 20 numbers. So we exclude 1. So actually, there should be 19 numbers. So we have 19 possible cases for A equals 2. So next would be A equals 3. So then this time B plus C will be 1 less. So it's only 21. What should be the possible choices for B? B also starts with 2, but this time it has to be end in 21 minus 2, which is 19. Of course, from 20 to 19, it's 1 less. So now in this case, we have 18 different solutions. And we can just continue this step directly to the largest possible value of A. What is the largest possible value of A? It is not 24, given that B and C each has to be at least 2. So 24 minus 2 again. So A equals 20 should be the largest possibility. And then in this case, of course, there's only one possible solution, which is B equals C equals 2. So here we have 1. Then you could know that in the middle it must be all the consecutive numbers. So from 19 to 18 up to 1, not up to 1, but down to 1. So 19 plus 18 plus 17 plus dot 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 plus 2 plus 1. Obviously, that is an arithmetic sequence. We know the magic formula to calculate sum, which is the first term 19 plus last term 1 times how many terms are there? 19 numbers divided by 2, which you would see that is exactly the same formula we just saw when we calculate the combinatoric numbers. 20 times 19 divided by 2. So the final answer is 190. So by listing them in a very clear and kind of like organized way, we can get the answer also quickly. The last AMC question is not that hard. So for AMC, the key thing is we solve the questions quickly so that you have time to do all the questions. Topic will be to discuss geometry problems in this computation.